Okay, so let's introduce you to the exposure triangle. Now, the exposure triangle is a way of considering and thinking about how photographic exposure works and balancing the three elements of aperture, shutter speed, and the ISO, or the sensor sensitivity. So this is really about trying to get these balance right, and by using more of one, it means you can use less of another, but you have got to get to the correct exposure, and if you have too much, then it'll be overexposed, and there's too little, then it'll be dark. So first of all, let's think about the ISO, the sensor sensitivity. This is normally considered in a scale from somewhere around 100 up to, these days, quite a bit over 6,400, but that's a good place for a high sensitive sensor to be. So the lower this number is, then the less the less sensitive it is to light, but the higher quality images it'll give. As you go up to the top end, then the sensor will be more and more sensitive, the number will be bigger, but the quality of the images will go down, and you'll start to have more grain, or noise as we would really call it in a digital camera. And then the main two controls we have, first of all, we have the aperture. Now, the aperture is the size of the hole, the size of the iris, which is letting the light through the lens and onto the sensor itself. Now, this is in a scale from f2 to f16 or more, and the best way to think of this is that it's a fraction. So f2 is effectively meaning that it's letting in half of the light, whereas if you were at f8, then you would be letting in an eighth of the light. So the smaller this number is, being a fraction, the bigger the actual hole is that it's going to let through, the larger the hole is that lets the light through. As the hole gets smaller, down to a 16th or a 32th or whatever, then the hole is getting smaller. The difference is that as the hole gets smaller, you get a larger depth of field, and there's more things that are in focus within the image. And as the number gets smaller, the hole is bigger, so the depth of field will actually become smaller. So that can have a creative use. You can use less depth of field to throw a background out of focus. But if you want an image where everything is in focus, maybe a set of people or whatever, and you want to make sure you're photographing a big group of people, then you want to make the depth of field much larger. So therefore the hole needs to be smaller and the number needs to be bigger. Then finally is the shutter speed. Now, the shutter speed is in a way the opposite of the aperture. It's doing the same thing but in a different way. So now the hole is open for a length of time. Again, this is normally a fraction, although we do occasionally go over that, and it's a fraction of a second. So in our normal exposures we might be working somewhere between a 15th of a second and a 500th of a second or a 1000th of a second, and each one of these fractions is smaller. The shutter is open for less time. So as the shutter is open for less time, the number will sound bigger, but remember it's a fraction, and it will give you the ability to freeze moving subjects. Whereas when the shutter is slower, then the shutter will be open for a longer time, which will allow things to move within that time, and things that are moving will blur. So if you want to make a balance where you want to have a very large depth of field with that small hole and a big number, it means that the light is going to come through it much slower because the hole is small. So in that case you would need to leave the shutter open for a longer period of time. So the good side of this is you get a large depth of field, but the problem is that then things will start moving and blurring as they're moving because the shutter is open for a longer time. So this is the balance of trying to get one against the other. But the important thing is you can make the decisions when it's going one way or the other, but the key thing is that you've got to always end up with the balance being right so that you have a correct exposure. So another way of looking at that is to consider on a graph. Now this is on a cloudy day, and we can see, no, I'm not going to do this, it's not right. So if you look here, the f11 is 1/25th, then we can also see that if we go up to f8, which would double the amount of light coming in, the hole is twice as big, but now it is open for only 1/250th of a second. If we then went up to have the hole open for a 500th of a second, that would be one stop again, and we would now need to keep the hole open for twice as long at 5/6. So all of these exposures will be the same. If on the other hand we go up to 400 ASA, that is twice as much. Now we're going to find that all of these figures go up one, and it actually needs one less of all of the things. So as you go up in the ASA, the ISO, then it goes up, and you need less light each time. If the light was that much brighter, it's a sunny day, then we see exactly the same thing. That at here now at 125th of a second, it's f16, 2/50th of f11. But if we go up 200 ASA, then it now is 2/50th of a second. 2/50th of a second at f16, 1000th of a second at f8, and if we go up one more, then again we can see up there. So we would expect this because there is quite a lot of light, and we would expect to be shooting up with quite small apertures, a small hole that isn't open for very long because there's lots of light around. But if we go to the other extreme and we go down to lighting under a candle, then there's very little light and our exposure times are obviously that much lower. What we're seeing here is a time of a 30th of a second at 5/6, or a 2/50th of a second at f28. And if we then go, now is when we actually need to have a higher ISO, and if we go to 200th or a 400th, then this is actually now showing that the speeds can go up and we're getting into a little bit more usable area. On the back of my old camera, my old Rolleiflex camera, we used to have a thing which is actually based on these EV values, exposure values. So these will actually show the number, and for each one of these numbers, let's say for 12 here, we can see that the exposure is f8 at a 60th of a second. If we want to work at f11, then we have to go to a 30th of a second, and f16 will be at a 15th of a second. So it's a very quick and easy way from actually just working out what the exposure is and balancing, or working out if you change the f-stop, how do you keep the same exposure time, the shutter time, to keep the exposure the same. And there I'll leave on the book a modern version of it which you can download and use if you find that interesting. So hopefully that's made things a little bit more understandable, and have a look at some of the other films, and we'll have a play with this, and please do ask me some questions in the forum.